All right, so in this video, I'm going to be showing you how to solve a rational equation. A little more on that. You've actually had one on your last test, okay? So problem number one is actually related to that. In question number one, you're being asked to determine where this expression is undefined, okay? So it says find any values for which the expression is undefined, okay? So the idea is this, that if the denominator, if you put in something for x that would cause the denominator to be 0, you'd be in trouble, okay? So it's based on the idea that division by 0 is undefined. Okay, so what we're going to do is set just the denominator equal to 0 and solve. So it turns out in this case to be quadratic, so we're going to factor. I'm going to use x and x. I'm going to use 5 and 9 because I can get a 14. I'm then going to set each of those factors equal to 0. And then I'm going to solve. I'm going to add 5 here. I'm going to add 9 there. So I wind up with x is 5 and x is 9 are the numbers that would cause x squared minus 14x plus 45 to equal 0. So if I put those in, the denominator would be 0, and that would be a problem. So that means x can't be 5 or 9. Okay, x can't be. I don't want it to equal 5 or 9, or the expression would be undefined because you'd have division by 0. Okay, now that's related to solving an equation you'll see in a minute. That's something we have to think about when we're working on solving an equation. Okay, so now I'm going to move to question number 14. We're going to look at 14 through 16. Number 14 should look real familiar. Okay, so number 14, we have 1 minus 6 over x minus 27 over x squared equals 0. And on these, we're being asked to solve. All right, so it's an equation, which is a handy little thing because if you have an equation, you can multiply both sides of the equation by the same thing. So what you do on rational equations is you look at the denominators and you think about what you could multiply by that would make that denominator cancel out. So to make x squared cancel out, I would need x squared, and x squared would also be big enough to cancel out x. So I'm going to use x squared. That x squared is called the LCD, least common denominator. So it's the smallest thing that would cancel out all of the denominators. Okay, now here's how we're going to use it. We're going to multiply the left side by x squared, and we're going to multiply the right side by x squared. Okay, so that x squared has to be multiplied by each thing. So I'm going to do x squared times the 1. And then I'm going to do the x squared times the 6 over x, because I have to distribute that x squared, don't I? And then I'm going to do the x squared times the 27 over x squared. And then I'm going to do, on the right-hand side, I've already got it there, I'm going to do the x squared times the 0. Okay, so that x squared has to be multiplied on both sides, and that x squared would get distributed. Okay, so this would become x squared. Here, x squared is really x times x. So one of the x's would cancel, and you'd have just 6x left. Then at the end, x squareds are going to cancel. You have minus 27, and 0 times x squared would be 0. Okay, so now that happens to be quadratic again. Has a squared on it, so that kind of determines what we're going to do from there. Sometimes this right here is linear, and it's not as much work, but this one's quadratic. So nothing's common. We're ready to just try to factor it. So I'm going to use an x and an x. And then with 27, my choices are 1 and 27 or 9 and 3. And I can tell 9 and 3 are going to work. So if I make the 9 negative and the 3 positive, I get the middle term here to be negative 6x, negative 9x and positive 3x. Okay. All right, so after that, after I know I've got it factored correctly, I'm going to set each factor equal to 0. I'm going to add 9. Here I'm going to subtract 3. Okay. I'm going to wind up with x equaling 9. Over here, I'm going to wind up with x equaling negative 3. Okay. All right, so seems like that's good. That's done. We've got our answers, x equals 9 or x equals negative 3. Here's the thing. You actually have to check. You must check to be sure these do not make the denominator, I should say any denominator, equal to 0, okay? So they wouldn't, because your original problem was 1 minus 6 over x minus 27 over x squared. So really the only thing that would make these denominators 0 would be a 0. So we know x can't be 0, but if I did all my other arithmetic right, these should be okay. All right. All right, so let's go ahead and try some that are a little harder. This is the one that you've seen already. You already had that on a test, but we're going to extend that idea a little bit. Okay. So I want to look at 15. All right, on 15 we have 16 over b plus 2. See how there's two terms down there? That's what makes it a lot harder. Equals 1 plus 2 over b minus 4. And see that b minus 4, I'm going to put them in parentheses, b plus 2, they're underneath that fraction bar. That's a factor. You know, that b plus 2 is a group, you know, together with parentheses. Think of it like that. All right, so with this one, first off, let's think about this idea, okay? You can tell looking at this one what's going to cause the denominator 0. Okay, if we put in a negative 2 here, see how a negative 2 there, see b plus 2 would equal 0, I can tell, if b were negative 2. So b better not turn out to be negative 2. If it does, I'm going to have to rule it out, okay? The other thing is b minus 4 equals 0 when b equals 4, because I could add 4 to both sides, couldn't I? Okay. And so I know I don't want b to be 4. So if during my solution process I wind up getting either a negative 2 or a 4, I'm going to have to rule those out. Okay. Now, before, when we had the problem earlier, it was a lot easier to see the LCD. We had the least common denominator being just x squared. Okay, the way I think about it is I'm looking for what it would take to clear the fractions, to get rid of the denominators. And so I take each one separately. So to get rid of this guy, okay, I know I'm going to need a b plus 2. To get rid of this guy, I'm going to need a b minus 4. So my LCD would be b plus 2 times b minus 4. I'd have to have both of those. Okay? So here's what I'm going to do. I'm going to multiply both sides by that. Okay? By that b plus 2 times b minus 4. I'm going to do that on both sides. All right. Now this side only has one fraction, right? So I'm going to take that 16, I'm going to do that in red, over b plus 2, and I'm multiplying it by the b plus 2 times the b minus 4. Okay, now those are really up here, understood to be up here, so that's why I wrote them high, okay, because they're just regular, they're not fractions, okay, so it's like they're over 1. All right, then on the other side, this right here has to get distributed to both of these terms. So I'm going to take the 1 and multiply it by b plus 2 times b minus 4. Hang on a minute. It just feels like a whole lot right now, but a whole bunch is going to cancel out in a second. And that's why we're doing it. We're trying to make this look a whole lot simpler. Then I'm going to take the 2 over b minus 4 and I'm going to multiply it by b plus 2 times b minus 4. Okay. Okay. All right. So here's my equal sign. Okay. I've got these different things all set up. I'm ready to just kind of see what happens and simplify things a little bit. Okay. So watch what happens. Here's a b plus 2. I can knock out that b plus 2. See, what we're doing is we're really clearing the fractions. I taught this in Math 98, but they only had numbers in the denominator. They didn't have variables. So now you guys have to understand how to do this with variable expressions in there. But it's still just clearing the fractions. You just multiply by the LCD, and then it's amazing what happens. So here we have the 16 times the b minus 4. Okay. Then over here, these nothing cancels. We just have 1 times b plus 2 times b minus 4. We'll multiply that out in a minute. And then over here, do you see how there's a b minus 4? That'll knock out the b minus 4 on top. The reason we picked b plus 2 and b minus 4 to be part of our LCD right here, okay, this LCD, is because by using both of those, I'm knocking out the denominators. But I can't use one thing on one side and something different on the other. That's why they had to both be there all the way through. So then here I have a 2 left and a b plus 2. Okay, so already it's much improved, okay, because I don't have the fractions to think about anymore, okay? Now at this point, I'm going to do some multiplying and some regular kind of equation solving stuff. So I'm going to distribute. Here I'm going to FOIL. Here I'm going to distribute, and then I'm going to see what I got and decide how to go from there. So this would be 16b minus 64. When I FOIL this, I'm going to get a b squared minus a 4b plus a 2b minus an 8. Then I'm going to distribute the 2, and I'm going to get a 2b plus 4. Okay. All right. Now, at this point, it's best to go ahead and get your like terms combined on each side separately. So 16b minus 64, I'm just going to hold off on that. That's fully simplified already. But over here, I've got all these b terms. So negative 4b plus 2b would be negative 2b. And then I got a positive 2b. They happen to cancel out. That doesn't always happen. So I see a b squared left here. And then I've got a negative 8 and a positive 4, which I can put together. They're on the same side, so I'm just combining like terms. And I get b squared minus 4. Okay? All right, so now here we are. And at this point, we have to make the determination. At this point, I'm looking at whether it's linear or quadratic, basically, are the two things that could happen. You see the squared right here? Because that's a squared, I'm going to work on this like I would a quadratic equation. I'm going to get it equal to 0 and then go from there. All right, now I like my b squared term to be positive. Okay, so I'm going to go ahead and move the 16b and the 64 to this side. I'm going to go this way with it. Okay, when I do, I have to subtract the 16b and add the 64. So that would be b squared and then minus the 16b, and then the 64 is positive and the 4 that was already there was negative. So that's going to be plus 60. Okay, so now I've got the 0 on one side. It's a little easier sometimes to think about with the 0 being on the right. So at this point, it's, like we said, it's quadratic. I got it equal to 0, so I could try to factor. So that's going to be a b. And then 60 is a bunch of things, but I'm trying to get a 16. So I think a 10 and a 6. That can take some time, that factoring step. Just take the time you need. Okay. They need to both be negative to get a negative 16b. And then the negative 10 times the negative 6 is positive 60. So then we'll set each of those equal to 0. Okay. We'll add 10, and we'll get b equals 10, or here we'll add 6, and we'll get b equals 6. Okay? So let me squeeze this down so you can see the whole problem, because these do feel overwhelming, okay, when you're first learning them, because there are a lot of pieces to it. So you look for how to get rid of the fractions, you clear the fractions. So once you identify the least common denominator, you're just going to multiply all the way through by that. It resulted in an equation that had a lot of distributing and multiplying to do. So I did all that. And then remember, it works best to get each side fully simplified. And then because it was a squared, I worked on getting a 0 on one side. Okay. Then this one factored. And when I set the factors equal to 0, I got 10 or 6. Now, assuming all my arithmetic and work in there is okay, I still need to check on something, because even though I might have done all of this right, 10 and 6 may not work in the original. I have to consider that. The question you have to ask is, do either make the denominator 0? Don't forget to ask that. Okay, so you really need to think about that. Do either make the denominator 0? So you look at it and you can say, well, no. The original denominator, we already did that, remember? It was only if we put a -2 in for b, or if we put a +4 in for b. That's the only thing that would make the denominator 0. Okay, so my answer is no. So those should be okay. Now, we are assuming we haven't made any mistakes. I'm not really checking for arithmetic mistakes. What I'm saying is, if you did everything right, sometimes these two answers don't both work in the original. They both work here, but you have to make sure that they don't make a denominator 0. All right, and then I had one more example kind of like that one. So let's try another one. All right, let's look at number 16. Number 16 is 1 over m minus 4 minus 6 over m plus 4 equals 3 over m squared minus 16. Okay. So I'm going to look for the least common denominator. But do you see how that m squared minus 16 can really be factored into m minus 4, m plus 4? So my LCD, my least common denominator, what I could use to clear the fractions would need to have an m minus 4 in it to get rid of this guy. And to get rid of the second one, I'd have to have the m plus 4. But then do you see the m minus 4 and the m plus 4 both be in there would get rid of the m squared minus 16, because that's really m minus 4 times m plus 4. Okay, so you want to factor your denominator so you can really tell what the least common denominator needs to be. So that's it. Okay. Also, before you start, I think it's a good practice to look at the denominators and think, okay, for this one, m better not be 4, because if I put a 4 in, the denominator would be 0. Okay. And then on that second one, m better not be -4, because if it were, I'd have division by 0. Okay, and then either one of those would cause a problem on the one on the far right. So this I kind of just put on hold for the end of the problem, okay, to check my answers and see if either of my answers is one of those. All right, so what we're going to do is we're going to multiply each of these fractions by that least common denominator. This I'll go ahead and write it in factored form. Okay, so I'm going to be multiplying that by m minus 4. Remember, you've got to multiply both sides, and if there's more than one term, you have to distribute it, okay? All right, so here's why we did it. Because it's going to knock out all the denominators. Here the m minus 4s go. Here the m plus 4 would go. Here the m minus 4 and the m plus 4 would go. And so the original problem is now just going to be 1 times the m plus 4 minus 6 times the m minus 4 equals just 3. Okay. So I'm going to get rid of the fractions. Okay. And then I'm going to look and decide how to proceed from there. This could be linear or quadratic. See how there's no squareds? Okay. It's not quadratic. It's just a linear equation. Okay. So I'm just going to collect my like terms together on that left-hand side. The m minus the 6m would be negative 5m. They're on the same side of the equal sign, so you're just combining like terms. The 4 and the 24 are on the same side. So that would be 28. Okay. And then here, it's a linear equation. We're just trying to get the m by itself. So we're going to subtract 28 because we're trying to go across the equal sign. So we're trying to make this go away. And we have negative 5m equals negative 25. And then that's multiplication, so we undo it by dividing. Okay. All right, so then we'd have m equals negative divided by negative is positive 5. And we already determined that the only thing that would be only numbers that would be a problem would be a 4 or a negative 4. And so we know this doesn't make the denominator 0. And if it doesn't make a denominator 0, assuming we haven't made any arithmetic mistakes, that should be it. Now, of course, you could plug it in for the m to make sure the two sides are equal, but we're really just assuming our process is correct, and we're just having to see if it makes a denominator 0. So the answer should be m equals 5. All right, so 14, 15, and 16, we're solving a rational equation. You do that by multiplying through by a least common denominator. You've actually done that if you took Math 98, but you didn't do it with variables. You did it just with numbers, okay? All right, so that's going to take some practice. So there's some homework that you can use to practice that. Question number 1 just asked what causes the expression to be undefined. So you just had to look at the denominator to see what you needed to rule out, okay? Because these original problems have these denominators. So that's what's kind of unusual about this type of equation is you could have done your whole process correct, but if we had wound up getting a 4 or a negative 4, we would have had to rule it out. All right, so let me post this and then I'll do some of the new material.